like less than I have the we have so much.
Alright, for this AP question, average rate of change on the closed interval average rate of change just means the slope between 2 points, and they tell us what 2 points to use, right? X is 0 and X is 10. So I'm just finding the slope between this point and this point. So slope is y2 minus y1 over x2 minus x1. So we would just have 5 minus negative 20 over 0 minus 10. So 25 over negative 10, which reduces to negative 5 halves. So B. All right. We okay with average rate of change? So the reason we did an average rate of change question today is that the lesson is going to be average value, which is a completely different thing that students often get mixed up. Okay, so we need to make sure that we're keeping average rate of change straight with average value. But before we get into that, how did the homework go?
I kind of forgot what we did last week, and when I did it, it was really easy, but I can't remember a lot.
Okay. I feel like I didn't do the best job of explaining what was actually going on. I mean, we talked about the formula, but I mean, the idea was you're given something like this, right, and asked to find the derivative of this, right? So a derivative of an integral, okay, those two things should undo each other, just like a square and a square root. We're adding and subtracting. They're inverse operations. So what we expected was to say, well, this would just, if I take the derivative of this, let me say d dt of this, right, the derivative of this, we would expect the derivative in the integral to just cancel out, and we would get this function here, right? But we realized that that's not exactly how it works. Okay? We realized that, well, we had to plug whatever this function was into here. So we would have f of g of x, then times the derivative of that inside function. Okay, so that was the formula that we talked about on Friday, right? Taking the derivative of an integral kind of cancels them out, right? Plug whatever this is into our function, then times the derivative of that inside. Right? That is something that needs to be memorized, right? I keep saying we're going to have a memorization quiz soon and then don't have one, but we will have one at some point, and this will be on there, okay? But before we do that, I'll give you a list of everything that is going to be on there, just like we did for the derivative memorization thing, right? So, I don't know, maybe next week sometime we'll do that memorization quiz.
I just told you not to.
Oh, also, if you weren't here on Friday, make sure you grab an AP practice. I passed out the AP practices on Friday for the week. And if anybody has their last week's AP practice to turn in, I did not get a lot of those last week. Okay. It should be in the top and the bottom there, on the top left. Yeah. So no homework questions? Felt all right with it? All right. Then today, we're going to talk about mean value theorem for integrals, or also known as average value. So, area under a curve, which is the entire premise of an integral. So we can say that the inscribed area, which just means find the lowest point and draw a rectangle. Okay. circumscribed area just means find the highest point and draw a rectangle. Obviously, this is an underestimate. This would be an overestimate of the actual area. Okay, kind of like what we did with Riemann sums. Just thinking about a single rectangle, though. The mean value theorem says that somewhere in between these two values, right, this area of an inscribed rectangle and this area of a circumscribed rectangle, somewhere in between these two values, there is an x value that will correspond to the exact area under the curve. Okay, so I can draw a single rectangle and say this rectangle is equal to this exact area under the curve. Okay, if I were to find, using our fundamental theorem of calculus, if I were to find that exact area, the mean value theorem says, well, I can also find some value in between A and B such that I can just draw a rectangle and it will have the same area. Okay? The reason this is useful, okay, well, I guess first, right, copy this down. Okay, this is what the actual mean value theorem is. Okay, if we take the area under a curve, okay, it's the integral of something from A to B. I think I cut that off your notes, didn't I? Yeah. So copy that down here. Oh, it is on there? Oh, okay. Oh, yeah. Okay, so what this is saying is the area under a curve is equal to the x distance, okay, the distance from A to B times some y value. Okay, so what this is saying is the exact area under the curve can be expressed as the area of a single rectangle. Okay, the width of the rectangle, the difference between my bounds, times some y value. Okay, where C is somewhere in between A and B. So the reason that this is useful, okay, we can use this to find the average value of a function. So this here, okay, is usually the way that we see average value expressed. Okay, it's the area under the curve, okay, which is the integral from A to B of our function, times 1 over the difference between my bounds. Okay, this will get me the average value of a function. Okay, and we'll look at plenty of word problems, okay, where this is applicable. Now, the reason, okay, that this works, okay, if I take that mean value theorem that we just had, where we said the area under the curve is equal to the y value times some x value, right? The difference between b and a times some y value. Well, all we're doing is dividing both sides by b minus a and saying the area under the curve divided by the x value will get me the y value. Right? This is the average value of a function. Right? So let's try one. Okay, let's find the average value of a function. And you'll see questions worded just like this on the AP test. Here's a function, find its average value on the interval 1 to 4. Okay, so to set this up, okay, if I want to find average value, what I want to do is find the area under the curve, and they give me my bounds, so from 1 to 4, of this function of 3x squared minus 2x dx. And then I'm going to multiply that by 1 over b minus a, so 1 over 4 minus 1. Right? This will get me the average value on that interval. So we know how to solve this now. Okay, to solve this, I'm going to find the antiderivative. Plug in 4, plug in 1, and subtract. But I'm going to have this 1/3 out in front. Right? 1 over 4 minus 1 would just be 1/3. So I'll tack that on. And then I need my antiderivative. So what's the antiderivative of 3x squared minus 2x? It's x cubed minus x squared. And I want to evaluate this from 1 to 4. So what that means is I'm going to plug in 4 into this. That 1/3 is still going to be out in front of all of this, right? So I'll have 4 cubed minus 4 squared minus 1 cubed minus 1 squared so we get 1/3 times 64 minus 16 would get me 48. Then minus 1 cubed minus 1 squared would just be 0. 1 minus 1. So this is just 1 cubed times 48, or 1 cubed, yeah, 1/3 times 48, which is just 16. Okay, so what we just found is the average value of this function of 3x squared minus 2x. In between x equals 1 and x equals 4, the average y value is 16. Okay, so far? So then the second part, find the values of C guaranteed by the mean value theorem. What that's asking me to do is find x values where we get a y value of 16. Right? So we found that the y value is 16. How would I then find where the x values are that correspond to a y value of 16? Well, yeah, which is plugging it in for y, right? So I'm going to say 16 equals 3x squared minus 2x. So how do I solve that? Right, it's quadratic, so we want to get everything on one side equal to 0. Now what? Yeah, see if we can factor it. Factoring doesn't always work, but that's the easiest way, so it's worth it to see if we can factor. And so if we want to think about x factoring, we want two numbers that multiply to negative 48 that add to negative 2. 8 and 6, and the 8 would have to be negative. Right, so I have to factor this by grouping. Right? So we can say 3x squared minus 8x plus 6x minus 16. Why would I do it? It doesn't matter. You can do it however you want. But it does not matter at all the order you put those in. So we get 8/3 and negative 2. Now, both of those are not answers to this. Does anybody see why only one of those is an answer to this question? Our interval is 1 to 4, right? So the only one that is on that interval is 8/3. Negative 2 is not on that interval. Okay, so the only value of C guaranteed by this mean value theorem, okay, is 8/3. So on this interval, 1 to 4, this function reaches a y value of 16 at 8/3, or 2 2/3. Okay. Questions on average value? All right, then let's take it. So for this, we're going to need a calculator. So grab a calculator.
Did you press close again? What? Did you press close again?
Yeah, but I'm on first. There was a lot of pull up because so I tore down my parking. Dude, I'm gonna make it. I'm going to the parking lot like 7:30. Ow. Yeah, I already said what?
When did your graduation?
The 22nd. It's not. 23rd. Yeah, definitely. Definitely we can
All right, so on this one, it says in 2000, the world's population was 6.1 billion. The relative rate of growth was 1.4% per year. This can be modeled by this function. N of t is equal to 6.1 times e to the 0.014 t power, where n is the people in billions and t is the number of years since 2000. Assuming this model remains true up until 2050, find the average population of the world between 2010 and 2020. So first, before we figure out how to actually solve this, we need to set up our integral. Right? See what I hit. So I'm finding average value, right? Average population. How would I set up my integral? What would that look like? Yeah. Well, so it tells us that the t is the number of years since 2000. So if my lower bound is right, okay, so my bounds are going to be 10 to 20. And I'm integrating this function, right? So 6.1 times e to the 0.014 t power dt. So first, I guess before we talk about average value, what would this integral get if I just found this integral? It would get me the change in population from 2010 to 2020, the total population change. But now if I want the average population, what should I do? No. Not take the derivative. Yes, but I need to, there's one piece I'm missing.
Oh, the outside of A minus B.
Right, the 1 over b minus a. So that would be 1 over 20 minus 10 in this case. Okay, so now we want to integrate this. This is an ugly function, right? Probably don't want to try to do this by hand. So let's do this on the calculator. On the calculator, if we do math 9, okay, from the home screen, math 9, we'll bring up, because the majority of the AP test is non-calculator. That's why. Yeah, so we can plug in exactly like we have here, right? It should, yeah, you got to do math 9 first.
Sorry, I was distracted by your.
What was in there?
Like,
Interesting. Yeah, we can put it in exactly as we have it right here. I mean, you can always change your variable to x. But yeah, I mean, you could put in a t. 6.1.
So then would it be dx?
Yeah, if you change your variable to an x, it would be dx on the end then.
Oh, wait.
That was the rate of change.
That's the average value.
Okay.
So this is saying in between 2010 and 2020, the average number of people was 7.5 billion.
So what do you do then? 75.
I multiplied that by 1/10.
Okay.
1 over 20 minus 10, which would just be 1/10. Okay, so whenever we're finding average value of something, we're using this format: 1 over b minus a times the integral of our function. Okay, we okay with this one? All right, so let's take a look at this one. And in this example, all we're going to do is talk about what these two integrals would be. So C of t represents the daily cost for air conditioning in dollars per day, where t is the time in days, and t equals 0 corresponds to July 1st, 2017. Explain what these two expressions mean. So the first one is just the integral from 0 to 90 of C of t dt. What would that represent? Not the daily cost per day, but so if I'm integrating a rate, right? So this function is the cost per day, and if I'm integrating that from 0 to 90, that will be the total cost for that 90 days. Yeah, right? So this will be total cost for 90 days from July 1st, 2017. So now, if I throw a 1 over 90 minus 0 out in front of that integral, what would this represent? The average cost per day. Right? So this would be the average cost per day for the 90 days from July 1st, 2017. Okay, so if we integrate a rate function, that gives me the total of something, the total cost, the total less distance traveled. Okay? If I then throw 1 over b minus a in front of it, that gives me the average value of that over that that interval. Questions? All right, let's do this last example here. We'll skip the last page today. On October 14th, 1947, Chuck Yeager flew his X-1 rocket plane at an altitude of 12.8 kilometers. He was clocked at 299.5 meters per second, which is about 670 miles an hour. Okay, at different altitudes, sound travels at different speeds. We can model the variation for speed of sound with this piecewise graph. Okay. So what we want to do is find the average value of this, okay, the average value of the speed of sound. So before we do that, before we actually calculate all of this, okay, if we look at the graph, I mean, it's probably, we want to find average value of this, probably going to be somewhere in here. And if we're just thinking about the average y value that this graph attains, but to actually calculate that, I'm going to find the integral of each of these pieces. Right? This is a piecewise graph just broken up into 5 pieces. So first, we want to set up our integrals. And since this is broken up into 5 different functions, we'll have to have 5 different integrals. Right? So the first integral, right, would be negative 4x plus 341 from 0 to 11.5. Right? And then if I want the average value of that, well, I would just multiply this by 1 over 11.5 minus 0. Okay, so let's practice using the calculator for this problem. We don't need to do all 5 of these by hand. Okay? So go ahead and set up each of these 5 integrals and calculate the average value of all 5 of these functions. Do I have to take away your half point?
Yeah, you can't. Yes, you can.
I don't know. I feel like you should be able to.
I didn't even say that. She told me I suck because I can't breathe. And every time I breathe, she laughs at me. Like my nose all stuffed up, but my throat's also like swollen. So how do I cry?
Did we get these values for all 5 average values? So what should I do with all 5 of these then to find the average value over the entire interval? Yeah, so one way to get a good estimate would be to add all 5 of these up and divide by 5, right? That would get me the average. This won't get me the exact average though, because some of these intervals aren't the same size. Right? This one has, what, 11.5, this one was 9.5, this one has an interval of 10, this one's 18, this one's 30. Right? So that'll get me really close, but it's not going to get me the exact average value. How could I get the exact average value? So, yeah, that would be the way to find the exact average value, right? We would find the entire area under the curve, and then find the average of that, which would be the same as multiplying by 1/80. Now, with what we've done, that's really easy to do. Okay? All we would have to do is take each of these values and multiply them by that difference on the intervals, right? So for example, this one, 318, I would multiply by 11.5. 295, I would multiply by 9.5. Okay? The difference between those intervals. 298.75, I'd multiply by 10. 316 by 18. 307 by 30. Add all of those together. That would get me the total area under the curve. And then I can take that total area and multiply by 1/80. I'm seeing some blank stares. Okay, all right.
Like in the second part that we
Yeah. Yeah, so what we're trying to find now is the actual average value of the speed of sound over this entire interval. Yes.
You already know what I said. So that's where yeah. You need to check yourself.
There's nothing wrong with making sure. She knew that. She was,
Yeah. Check every other test you've taken in here.
Okay, on the last day she practiced, she was like
The only thing is because I thought it said maximum.
No, you thought it was the increase is decrease. Yeah, you did that.
Maddie was sitting in the room.
Do we have to like pretend we're in kindergarten, go around the room and say one nice thing about each other?
I don't know what it is. That was like 5 hours.
Alright, did we get 308? 308 kilometers per hour? I guess that wasn't kilometers per hour, that was meters per second. I thought that was kilometers per hour. 308 meters per second. Is that what we get? Sure. So 308 meters per second is about 689 miles per hour. So the average speed of sound from altitudes of 0 to 80 kilometers is about 689 miles per hour. All right. Questions on average values?